Previously, we learned that in a series circuit, the electric current passes through a single path, whereas in a parallel circuit, the electric current is divided into branches, and your electric current will pass through all the different components in the different branches of the parallel circuit. So how do we measure the current that passes through the components or in the electric circuit? Okay, we measure the current using this instrument called an ammeter. So this is how the ammeter looks like in the lab, and it has got two terminals, the negative terminal and the positive terminal. Okay, so when you set up your electric circuit in the lab, the negative terminal of your ammeter must be connected to the negative terminal of your cell or battery, and the positive terminal of the ammeter must be connected to the positive terminal of your battery or cell. Okay, so this is how your electric circuit diagram will look like. Okay, so you have the positive terminal of the battery connected to positive terminal of ammeter, negative terminal ammeter connected to negative terminal of the battery. And you find that the ammeter is connected in series with the battery, ammeter, and bulb all in one single path. Okay, so ammeter must be connected in series in a circuit, and when we draw the diagram, ammeter is represented by a circle with a capital letter A in the center. Okay, we've been talking about electric circuit. An electric circuit is actually a complete or closed path through which the charge can flow from one terminal of an electrical source, for example your cell or your battery, to the other terminal. Okay, so this closed path or complete path that the charge can flow from one terminal to another terminal, this is called an electric circuit. And in an electric circuit, there are four main components. First, you have a source of electromotive force or EMF that drives the electric charge around the circuit. So this source can be your cell or your battery. Two, a load on which the moving charges can do a useful job. For example, a light bulb. So when the charges passes through this load, it can light up the bulb, do something useful with it. Okay. 3, you have conductors to connect the components together, like all these connecting wires or copper wires to connect your batteries and your bulbs together. And we also have switches to open or close the circuit. So these are the four main components. Of course, you can add on your ammeters in series inside the circuit to help to measure the currents that is flowing through the electric circuit. Okay, so electromotive force or EMF of an electrical source is actually defined as the work done by the source in driving a unit charge around a complete circuit. Okay, now in the electric circuit, when the switch is open, then there is a break in the circuit, and you find that the current is not able to flow through in the circuit. We say that you have an open circuit, and this occurs when there is a break in the circuit to stop the current from flowing through. Next section, we are going to look at this new term potential difference represented by symbol capital letter V. Just now, under electric circuit, we say that one of the four main components is your battery, which is a source of electromotive force or EMF that drives the electric charge around the circuit. So we know that electric charges need energy to push them along a circuit. And just like water, which always flows from higher to lower ground, positive electric charges also flow from a point of higher potential to a point of lower potential. Like this waterfall here. The water at the top of the waterfall has more potential energy compared to water near the base of the waterfall that has less potential energy. And the water always flows from this higher ground with higher potential energy to the lower ground with less potential energy. So your electric charges will also flow from a point of higher potential to a point of lower potential. So an electric current can only flow when there is a potential difference, PD. Okay, P dot D dot small letters, and the symbol is capital letter V. So what is potential difference? Potential difference, or PD, between any 2 points, must be between any 2 points, is the amount of energy needed to move 1 unit of electric charge from one point to another. And the SI unit of potential difference is the volt, also with symbol capital V. So 1 volt of potential difference means that 1 joule, capital J, of energy is needed to move 1 unit of charge. So the more energy needed to move a charge between 2 points in a circuit, the greater the potential difference between the 2 points.